Consider the function f which has a domain of 0 included to infinity, mapping to the real number system, where f of x is equal to 2 times the square root of x plus 1. For part A, we want to determine the coordinates of the point P, where the equation of the normal line is y equals negative 2x plus 13. So the first thing we can identify is that the gradient of the normal is equal to negative 2. And that's because that's the coefficient of x in the normal line. And we know that the gradient of the tangent is related to the gradient of the normal. And if we're given the gradient of the normal, we can find the gradient of the tangent as being negative 1 divided by the gradient of the normal line. Therefore, the gradient of the tangent is equal to negative 1 divided by negative 2, which is equal to positive 1/2. Next, we need to find the x value that has a gradient of the tangent being 1/2. And to do that, we're going to need to differentiate f of x. So first off, we can also write f of x as equaling 2 times x to the power of 1/2, because that's the same as the square root, plus 1. And when we differentiate that, we'll find that f dashed of x, the derivative of f of x, is equal to, and we take the power out the front, so we have 1/2 multiplying 2x, and then we take 1 off the power, so it's going to be to the power of a negative 1/2. And simplifying that down, we'll find that f dashed of x, the derivative, is equal to 1/2 times 2, which cancels, and then x to the power of negative 1/2 can be written as 1 divided by, and the negative puts it into the denominator, and the half turns it into a square root. So the derivative is equal to 1 divided by the square root of x. So next, to find the x ordinate of the point P, we simply let f dashed of x, which is 1 divided by the square root of x, equal 1 divided by 2, which was the gradient of the tangent that we found over here. So if we have a look at that equation, we can see that the square root of x must equal 2, and squaring both sides, we find x must equal 4. So now that we've got the x ordinate or x value of this point P, to find the y value, we need to substitute x equals 4 into f of x. So we can write f of 4 is equal to 2 times the square root of 4 plus 1, and that's equal to 5. And that means that the coordinates of the point P are going to be 4, 5. So that's the answer for part A of this question. For part B, it says, hence determine the equation of the tangent to the curve at the same point P. So we already know that the gradient of the tangent is equal to 1/2, and that was found back up here. And we also know that it passes through the point P, which has the coordinates 4, 5. So as we have the gradient and the point that it passes through, we can use the formula y take y1 is equal to m, the gradient, times x subtract x1 to find the equation of a straight line. So substituting in what we know, we're going to have y take, and the y1 value is going to be the 5, so we're going to have y subtract 5, which is equal to m, which is the gradient's value of 1/2, times x subtract x1, which is going to be this 4 here. So we're going to have x subtract 4 in the brackets. And then simplifying that, we'll find that y subtract 5 is equal to x divided by 2 when we expand the brackets, subtract 2. And then if we add 5 to both sides of the equation, we'll find y by itself. And that will give y is equal to x divided by 2 plus 3. So that is the equation of the tangent line to the point P, which is what we were asked to find in part B.